Okay, so hello from my side. Today I will talk about Qwik, and because I have 10 or so minutes, this presentation better be really quick, no pun intended. Before we start, just a couple of words about me. So, my name is Blagoj, I come from Macedonia, and I work as a principal software engineer at G&D, etc. Three things that I like doing: traveling, running, this is sort of on hold for the time being, and last but not least, coding. So, we start with what is the thing that makes Qwik achieve fast rendering times. And there are two things: delayed execution and resumability. Delayed execution means to load immediately, or at least as soon as possible, while for the resumability, in order to explain it, we need to explain first what hydration is. Usually, being hydrated is a good thing, but not in JavaScript, because it has great impact on the loading time. So, there is this thing called server-browser handoff, and this is where the state, instead of being resumed, it needs to be recreated when it is being passed to the client, in this case the browser. And in order to do this, the browser first needs to fetch the HTML template, then go through all of the reactive part, which is the JavaScript, download all the part, execute it, in order to restore the application state, the components, and then to find the event listeners and bind them. What Qwik does is that it executes only the first stage to get the HTML, because everything is already serialized there, but it is being lazily loaded on demand. We will see in the next slides how. These are the four things that Qwik does in order to achieve these lightning fast times. The first one, of course, to serialize all the JavaScript within the template. The second thing is to serialize the component trees, meaning during the server-side rendering phase, the browser needs to know when one component ends and the other one starts. The third thing is to make a reactive graph between the components and the application state. Here we're talking about reactive variables that I will refer to as signals. So it is important to know which variables are used in which template, so when the rendering phase comes, to render only what has been changed and not re-render the whole component tree. And the last thing is independent restoring of application state, meaning that in some of the frameworks, in order to restore a child component, you need to go through the whole hierarchy tree, and in this case, it's important to restore only an isolated component if possible. What are the four building blocks of Qwik? First is the serializer, obviously, because there is a component that actually needs to serialize on all the states so that it can be resumed when the browser handoff happens. Second, we have the optimizer. So this is a component that is responsible for the chunking. This lazy loading requires a lot of chunks, but on the other hand, the optimizer also needs to bundle this in order not to trigger waterfall of network requests. So it is important that these small chunks are grouped logically together so that we can load them faster. The third thing is the loader. So there are two things here. We have a quick loader. This is a small executable that is being shipped with the initial template, and its responsibility is to find this serialized state, create the whole location, and then hand off to the browser for the execution. But also we have a preloader. So in the template, when we have this text, the browser can be signaled with some preload flag that this component is very likely to be requested immediately, and it needs to be preloaded. The last thing is the proxy. So this is about the reactivity that I was talking about. For these reactive variables, there are some interceptors on the getter and setter methods so that we know when they are changed and then re-render them properly. And these interceptors are called proxies. So we have an example. Here is one most basic counter component. What happens now is that the optimizer is chunking this in three pieces. The first one is the QRL of the main component. Then we have the onMount part, which is basically the application state. We have the onRender part, and in the onRender part, we have this onClick method, which is an event listener, and this ends up also in a separate chunk. Then what happens during the rendering phase? So here we have the document URI is not seen, we have a base URI, and we also have some variables. Once they are concatenated and in this onClick event, we see this last chunk that was created. And then we have the quick loader that basically, based on this data, creates the location, and then the browser executes the code correctly. Now, from practical point of view, so whenever you scaffold a Qwik application, this is what you get first. The main principles. First is the component, and then you see this dollar part. This dollar part is usually there to indicate the optimizer that needs to be lazily loaded. When you want to load data from the server, you use the route loader. This is a function, and then you can call a backend method. For this sample to-do applications, I'm calling an in-memory service. Sometimes we are calling a dynamic routes. So whenever we have the path variable, we have the request event, and from there, from the params object, we can get whatever we need in order to do the loading properly. One limitation of other current frameworks is that whenever you want to do deep links, you need to first forward to the index.html so that the router gets properly executed and the path is fetched. Qwik solves this into the simplest possible way. So in Qwik, unlike other frameworks, the directory structure actually resembles the router path, and then you have some not really intuitive folder names like this one, ID in square brackets, meaning that this is a path variable or dynamic part of the URL. And then in order to properly navigate, you can either use the link component and into the href create the dynamical path, or you can use the useNavigate hook, and then let's say on a click of a button, you just navigate to wherever you need to. Opposite to route loader is now that we want to send some data to the server, then we use route action, and in the route action we provide whatever needs to be persisted. Then we also have this use hook for the action, which can be put either on the form tag of the action attribute, or if we want to do this programmatically, then we can call the action submit and then pass the value of whatever we need to persist. Regarding the validation, so the built-in validation is with Zot. As we can see here in the example, so I have a simple to-do app that has two properties, title and complexity. And then, as we see, for the title, it's a string with minimum length of 1, meaning that it's a required property. And regarding the complexity, it can be one of small, medium, and large. And also, there is a possibility to override the default error messages in case the validation fails. How do we use them? So if we see here, we have the action value property, and on that one, there is a failed flag that is being set if there is a validation issue. And also, under the field error object, we have separate properties to indicate which one of the properties actually failed, and then the correct error message is being displayed. In case Zot doesn't cover anything, there is an option to use custom validators. So here, I just re-implemented more or less the same logic that is being done with Zot, and then I'm creating this error property manually. And there are some catches here. The failed flag is set as usual, but right now on the action value we see that there is no intermediate object, but rather these violating properties are attached directly to the action value. And what is really important is that these validators can be chained, and then the data from the one is transferred to the other one. And usually it is a recommendation that if you do not want to mutate the original data, you do not need to pass it forward. However, this applies only for the validator chain. But in order to finish with the validation, you need to pass this data object to the actual route action, because if you don't do it, then basically there won't be any data to be persisted. And the last thing, I didn't use it into the demo, but in case some variable changes, we might want to do some arbitrary action like a side effect, and for that we use the useTask hook. So first we need to tell which value are we going to track, then to execute the action when this value changes, and then there is an option if we want to do a custom cleanup afterwards. Okay, so now I will switch very briefly just to the demo. So yeah, this is the application. Of course, there is no CSS because I'm just a JavaScript developer. So we have this add to do item button, and then we can get a random to do, which is calling from this arbitrary site. And then we can also apply complexity to it. We add it. We can also edit in case we put here some invalid value, then the message will be displayed, the value returned to the original one. But the most important thing that I want to show is that about these startup times. So as we can see here, whenever I refresh the page, you see that almost everything is preloaded either from memory cache or for this cache. Of course, this first one we cannot avoid because it is a backend call, but for all of the other static resources, as we see here, they are loaded in around of tens milliseconds, which is actually why Qwik is achieving these lightning fast times. And with that, I will finish my presentation. Thank you for your attention.